integers. We're given two positive integers low and high. An integer x consisting of 2 times n is symmetric. 2 times n digits is symmetric if the sum of the first n digits of x is equal to the sum of the last n digits. Okay, numbers of it with an odd number of digits are never symmetric. Return the number of symmetric integers in the range low to high. Return the number of symmetric integers. Okay, so the low number is 1 and the high number is 100. Then the symmetric numbers are, has to be 2 digits, so 11, 22, 30. Okay. So here it's 4 digits. Yeah, the least is gonna be 4 digits. And it would need to be like 1, 2, 0, 3, 1, 2, 3, 0, 1, 2, 1, 2, 1, 2, 2, 1. And that's it. Okay, so first two numbers have to add up to the last two numbers in the range. Alright. So it's also pretty small in terms of the number of values that we're going through. 1 to 1,000, 10 to the 4th. No, 10 to the 3rd is 1,000, 10 to the 4th is 10,000. Yeah, it's like 1 to 10,000. The first, return the number of symmetric integers. So the first, if you have a starting digit of 0, that doesn't really count. So you could return this is similar to yesterday's, where you maybe can turn the function the function from 1 to high minus the function from 1 to low to get that, and then you don't have to worry about counting it from low to high, just counting it from 1 to high. I guess that's reasonable. If low doesn't equal 1, because 1 is the lowest value, then return self dot symmetric integers from 1 to high minus count symmetric integers from 1 to, because low is inclusive, it'll be low minus 1. Okay, so now we're just counting from 1 to some high amount. So how many symmetric integers? I guess it depends on how many digits the high amount is. Depends on how many digits the high amount is. Because if the number of digits is odd, then it really just goes down to the lower bound of evens. So I could also do something where if the let's say if the length of the string of high, which is the number of digits, is odd, then we're just going to go to the lowest, to like 9,900, a bunch of 9s with an even number of digits. So like if it's like, let's say it's 3 digits, right? Like the high is 100, then we'll just make it into 2 digits, 99. Or if it's like high as, well, any 3 digits, it'll be going to 99, 2 digits. So how to do that? I'll do actually I can probably do something like n is the length, n equals the length of the string of I, and if that number is an odd number, then return I nines is going to be the integer of, or let's not, I can use powers here. So if it's a two-digit number, then it's 10 to the first. So it's 10 to the power of n plus 1. Two-digit number, three-digit number, then I want to do n to the power of 2, which is 1 less than n minus 1 minus 1. So that'd be like, if it's 3 digits, then I want to get 99, which is 100 minus 1, which is 10 squared, which is 1 less than the number of digits. And then I'll just return self.count symmetric integers from 1 to the high nines. Okay, so now we're dealing with strictly dealing with 1 to I, where I is even number of digits. I wonder if it could be like, what happens if n is 1? N is 1, then we 10 to the 0, which is 1. And then 1 minus 1 is 0. I guess I could say here also that if the high number is a single digit number, then it's not possible. If I is less than 10, return 0. Alright, so there's that. So now what to do? So n is going to be the number of digits in the string where it's even. So but it could be that the ending of the string is an even number of digits. Where an integer x consisting of 2 times n digits is symmetric. The sum of the first n digits is equal to the sum of the last n digits, not including 0. Not including a leading 0. So it has to start with a leading 1 or 1 through 9. So it goes 1 through 9, and then any number from 0 to any number after that could be any number. But then it also needs to work with the ending digits, where the ending digits is smaller than so let's consider 1200 to 1230. So we're just going to consider how many things go up to 1230. So let's do function from 1 to 1230. So it's 4 digits. So either 2 digits or 4 digits. So all the 2-digit numbers are 11, 22, 33. So there's 9. And all the 4-digit numbers would be 1, 0, and then that could be like 1001, 1010, 1102, 1120, 1111, 1212, 1221, 1203, 1230. How to quickly calculate that? Sum of the first n digits is equal to the sum of the last n digits. So I can go up to the maximum. I can go up to the maximum value. Well, okay, so the low to high is 1 to 10,000. So this function is 1 to 10,000. 10,000 has, or that's equivalent to basically 1 to 9,999. So there's no 5-digit number that's possible. So it's 1 to 10,000, 1 to 9,999. If you take the first 2 digits, you take the last 2 digits. So what if you considered what digits there are currently in the high, and you saw the number combinations, the number, if you took the number that's currently high, so let's say that number is something weird, like 7,539. So your first 2 digits add up to 12, and your last 2 digits add up to 12 as well. But then you could do anything that is 6, anything that adds up to 6, or anything that starts with 6 is fine. So it could be 6 and then any number, or 5 and any number, 4 and any number. So the first digit could be anything that is one less than the digit that is currently there, and that number of numbers is 6. I guess it could be 1 through 6. So it could be 1 through 6, and then the next number is anything from 0 to 9, and the number combinations there would be 6 times 10, so that'd be 60. Because it'd be 1, 0, so yeah, that'd be 60. And then how many pairings of those 60 could you make with the ending? Well, for each number, let's say it was 64. How many ways could you pair 64 with some integers? So that's 10. So how many ways can get to 10? Well, you can do 0, 1, or 0, 9. No, you can't do that. But you can do 1, 9, 9, 1, 2, 8, 8, 2, 3, 7, 7, 3, all the way to like 4, 6, 6, 4, 5, 5. So 10 has 1, 2, 3, 4 times 2, so it'd be 8 plus 1. So there's 9 ways of doing that. So 6, 4 could pair with 9 different endings. 1, 2, 3, 4, 5, 6, 7, and 5 is not duplicated. Okay, and then you have 6, 3 possibly. That adds up to 9, so it'd be 1, 8, 2, 7, 3, 6, 4, 5, 5, 4. 4, 5, 5, 4, 6, 3, 7, 2, 8, 9. This one there is a 9, 0, 0, 9. So this one actually has 1, 2, 3, 4, 5, 6. It actually has 10 ways. And if it was 6, 2, I think this would probably be 9 ways. So it'd be 0, 0, 8, 1, 7, 2, 6, dot, 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 8, 0. Yeah, that's 9 ways. But what happens? Alright, so what if it's a bigger number than a let's say it's like a bigger number. Say it was 68, adds up to 14. So that could be 7, 7, 6, 8, 8, 6, 5, 9, 9, 5. And that's it. So what is the pattern? What is the pattern? So for any combination of first two digits that form a sum, if the sum is the number of ways to get to that sum, the number of other ways to get to that sum would be what? If the sum is 9, the number of ways is 10, if the sum is 10, it's 9. So does it peak at 10? Yeah, I think it peaks at 10, and the farther away from 9 it is, that's 1 less. So 14 is 5 away from 9, and therefore 14 has 5 less than 10 parents. Okay, so if S is sum of 2 digits, max is the ways to get it is the max ways is when S is 10 and the ways is sum is max is when sum is 9, ways is 10. Otherwise, in general, it's going to be the sum, the absolute value of the sum away from 9, whatever the value that is how less than 10 it is. So if 9 is 10, if it's 10 then it's 9. And if it's 14, then there's 5 ways. Is that right? 14 minus 9 is 5. 10 minus 5 is 5. That's only for 2, that's all I care about, 2 digits. I don't really care about 3 digits, 4 digits. Or I only care about pairings of 2 digits. Okay. And then I do have to care about but then for each number from 1 through 6, and then for each number from 0 to 9, I would need to calculate the sum. So for each number from 1 to 6, so 1 to 6, if it pairs with 0, then its sum is 1 to 6. Pairs with 1, like 1, 1, 2, 1, 3, 1, it becomes, the sum becomes 2 to 7. Oh, Jesus, how is this an easy problem? Must be missing something. I must be missing something. How many symmetric? I wonder if it's just should just go through and parse each. Go through and parse each number. Okay. All right. Fine. How about this? For num in range low to high, plus 1. I should probably make the low and high be an even number of digits. So if the low is less than 10, then I'm going to say the low is equal to 10. Else if the low is less than 1,000, then the low is going to be equal to that. So it's going to be at least 10 digits, or at least an even number of digits. And if the high is, well, if it's equal to, if the high is an odd number, it's greater than, so the high could go up to 10,000, which is 5 digits. So if it's, so if the high is greater than, what? I wonder if I care about the high at all, really. If the high is an odd number of digits, so if the high is, well, the high is less than 10, just return 0. So here the high is greater than 10. And if it's greater than 10, then the high is a 4-digit number. If the high is between, it's a 3-digit number, so let's say 100 through 999. Then I'm going to make the high 99. This is just so terrible. Maybe I should just count the 2-digit numbers separately. Maybe I should just count the 2-digit numbers separately. Okay, let's do something like this. 2s is 11, 22, 33, 44, 55. Okay. If none is in 2s, answer plus equals 1. The other number, no, this is just so stupid. If the number is 2-digit number, if it's 1-digit number or 3-digit number. If num is less than 10 or 3 digits, so 100 through 1999, then just skip it. Okay, the numbs and twos, you're gonna come up with the answer. Man, this is gonna be so fucking slow. Otherwise, I'm going to take the first 2 digits. If the number is less than 10, skip it. If the number is less than 100 and num is in twos, answer increases by 1. If the number else if the number is less than, so at this point the number should be like a 3-digit. At this point the number should be 4 digits, except for 10,000. I guess since I hear if the high is equal to 10,000, I'll just make it 9,900. So at this point the number should be 4 digits. So I could probably do something like the first digit is thousands, is going to be num mod. That hundreds is num mod. That, and answers incremented by this formula here. The sum, pair sum is going to be thousands plus hundreds. Answer plus equals to the pair sum minus 9, 10 minus the absolute value. So 10 minus the absolute value of pair sum minus 9. So pair sum is 1, then there should be 2 ways, right? 1, 0, 0, 1. So 1 minus 9 is 8, absolute value, and then 2. Alright, and then return this answer. The num is less than 10 or between 100. Num is equal to 100 or, okay. Pair sum, did I misspell something here? Oh, clear answer. Oof. 10 minus the pair sum. Oh, it's not mod 1,000, so divided interdivision. That's not right either. This is hundreds should be ignoring thousands. So mod 1,000 divided by 100. How do I get 90? What the hell? So just going from 1 to 9. Right. Shouldn't be hitting the else, I don't think. Huh. So num is less than 10 or between 100 and 99. That shouldn't work. If the num is less than 100 and oh, it could be 2 digits. No. If the number is 2 digits. No. Alright, look for that one. And then 1200 to 1230. So it's 4 digits. Oh, yeah. I'm doing it way too many times. So if I just look at the first 2 digits, I can ignore. Look at the first 2 digits. Ah, fuck it. Tens is num mod hundreds divided by 10. Ones is just num mod is mod 10. So tens, you look at the number of hundreds. Yeah. Yeah, mod 10 divided by 1. If thousands is hundreds equals tens plus ones, tens plus equals 1. This is the garbage solution. How is there so many other solutions that are slow? This is literally just going through all the numbers and calculating the digits. Yeah, okay. What are the solutions that are slower here? I did a very general conversion of numbers to strings and doing a bunch of crap. Well, not that I was above that. Alright. Let's just do summary. Note that the numbers the constraint on numbers is a very bounded range, 1 to 10,000, such that a more general solution might be slower. Here, broke it. Did a simple loop through all possible values in range. Identified that it either is 2 or 4 digits. If 2 digits has to be 11 to 99 multiple of 11. If 4 digits found the exact digit values and compare thousands, hundreds, tens, and ones, and checked for some equality. This is the mean time complexity. This is O of OV, where V is the range of values. Between low and high. I guess that could technically be yeah, space complexity. This is O1. No real data structure usage. Alright.